Hello everybody. Thanks for watching these videos, and I'm sorry to change the structure of the class for a couple of days. But anyways, let me just get right into it. So we're going to talk about applications of systems of linear equations. You know, we've been talking about matrices and using matrices to solve systems. And section 4.2 is basically it's word problems where we can use these techniques. That's kind of the way to think about it, is word problems that linear systems are useful. So let's just dive right in and take a look at an example. And some of these will be matrices will be more useful than in others. The harder they get, the more useful the matrices are, it seems to be. So let's go for it. We have a bag of 706 nickels and dimes worth $48.60 altogether. How many coins of each type do I have? So a couple of things you need to think about when you're doing word problems is what is the first thing, what is the question? So here's the question. What is the question? What am I looking for? In other words, what are the unknowns? Very important that you actually name the unknowns and even write them down, write it down on your paper. So in this case, how many coins of each type? That's what I'm looking for. How many coins? So the types of coins are nickels and dimes. So let's let n be equal to the number of nickels, and let's let d be equal to the number of dimes. Okay, and you see how I am very careful to actually write out what my unknowns that I'm looking for, what they really are. This will be, in this case, maybe you think, oh, I don't need to do that. Just get into the habit of doing it, okay? All right, so now we're going to start looking for equations that relate the variables, that relate the unknowns. And this is the hard part. Because you can't reduce this completely to just a formula. There is some I think practice involved in this that you just have to work through it. So anyways, one thing you can do is you can look for when you have a number, like, you know, you actually have like a value. Here's a value. And here's another value. Like, what are these things related to? So this value is related to number of items. So the reason I'm saying that is because I can probably write a number of item equation. And being explicit about what kind of equation I'm going to write is going to help me write that equation. Whereas this is a monetary value. So I can probably write a monetary value equation that uses each of these things, okay? So let's try to do that. Let's try to write a number of items equation. So on one hand, I have the number of items. That's 706 total items. And I have n as the number of nickels and d as the number of dimes. So this one's not too bad. I mean, I think we can probably all agree that if I add the number of nickels to the number of dimes, then I should have the total number of items here, which is 706. So there's an equation. Okay, so that's my number of items equation. And then for my value equation, this is a little bit trickier. Let me kind of, over here on the side, let me write something about value. I can say the nickel value plus the dime value equals the total value. Okay. Now when I say the nickel value, I really mean the total nickel value. And here I mean the total dime value. And why I'm being kind of careful about that is because when I say the total nickel value, I mean the number of nickels times the value of each nickel. Okay, so the total nickel value is going to be, and I'm getting a little tight in space here, but let's say the total nickel value is the number of nickels multiplied by the value per nickel. Okay, and then we need to do something similar for dimes. So for nickels, so how many nickels do we have? Well, we have n of them. So that's n times, and what's the value per nickel? This tends to be a silly thing people mess up on. It's 0.05. That's 0.05 because 0.1 would be a dime, 0.01 would be a penny, so this is 0.05. So that's my nickel value. Now, with this same idea, actually I should probably write it like 0.05 times n. Do you see that I could then say my total dime value, add that in there, and then my total dime value would be 0.1, not 0.1, but 0.1, another thing to be careful about, D, 0.1D, and then those two values added together has got to equal this $48.60. So the system is here. N plus D equals 706, and 0.05D plus 0.10D is $48.60. So I have a matrix here. This is a 2x2 system. You don't have to use a matrix to solve this, but I'm going to. So remember, with your matrix, you kind of have an understood one here and an understood one there, so that my matrix would, my coefficient matrix would be 1, 1, 0.05, and 0.10, and that would be my A matrix, and my B matrix would be 706 and 4860, and then I would need to do A inverse times B. Okay, A inverse times B. And here is the matrix system. Okay, you see how we've set this up. And then it's just a matter of plugging all this into the calculator. So here are explicit instructions as far as how to do that. We first would need to name our matrix A. It's going to be a 2x2 matrix, and then we type in these entries. Then we name our matrix B, which is going to be a 2x1. And then finally we do the matrix computation. And remember that when we do the computation, you have to do A inverse. It's not just A, it's A inverse times matrix B. Okay. And that gives us the value 440 and 266. So the way to interpret this is because we set our equation up with N first and D second. So you see how that shows up here? N nickels is first, dimes is second. So that's going, so whatever the uppermost number is going to correspond to the number of nickels, and the lower number is dimes. So this is nickels, and this is dimes. Okay, so there's our solution. So we have 440 nickels and 266 dimes. All right, so that's a basic application. You know, the matrix part of it is not the hard part. I don't think in this case. That's more the setting up the equations. But the matrix is useful. So there is our solution again. All right, let's look at another example. This is a classical mixture problem, and people always enjoy these to great excitement about mixture problems. So let's talk about the mixture problem. we have, oops, hold on a moment. Large quantities of a 4%, and remember the things to think about, sorry. We want to ask what's the question, what am I looking for, what are my unknowns, and find equations, okay? So, sorry, back to the problem. Suppose large quantities of a 4% methanol solution and a 14% methanol solution are available in a stockroom. Here's the question. How many gallons of each must be mixed in order to get 50 gallons of a 7% methanol solution? So the question is this: how many gallons of each? I mean, I know that the full question is this entire sentence, but this tells me what my unknowns are. My unknowns are the number of gallons of each being 4% methanol and 14% methanol. So let's let X represent number of gallons of 4%, and let's let Y represent number of gallons of 14% methanol. Also, we need to think about what this 4% and 14% and all this, and what are we trying to do? We're trying to get 50 gallons of 7%. So, we're trying to achieve a certain concentration of this substance. So X and Y, we have our unknowns, and now we look for equations that are relating our unknowns, and oftentimes we look for the other numbers to tell us about our equations. So what kind of equations we can write. So the first number I see is this, I know that I have these concentrations, and those are going to be important, but I also have this number, 50. So I want to get 50 gallons. So 50 is a total amount, and that gives me a clue because I can write a total amount equation, and my total amount equation is going to say I want to get 50 gallons of stuff, and it's going to be comprised of X gallons of the 4% and Y gallons of the 14%. So there you go, there is one equation written already. Okay. Okay, so our second equation, let's look for another number. So we have this percent, all these percents. This is going to be a little harder, but we're going to need to write an equation that uses these percents in some way. And I'm going to pause my video because I have a recording limit time, so I'm going to pause the video and restart the next video. I will pick it up right here in getting this second equation, okay?